In this video, you will learn about exponential and logarithmic equations. So first off, let's talk about solving exponential equations. So our property that we're going to use to solve exponential equations is that if b to the x power equals b to the y power, then x would equal y. Meaning if the bases are the same in this equation, then we can set the exponents equal to each other. So for example, if we had 2 to the x power equals 2 to the 4th power, because the bases are the same, then the exponents must be equal. So x must equal 4. All right, so we can do that for any type of exponential equation. So here, for example, we have 3 to the 2x minus 1 power equals 27. Now, for this to work, we have to have both bases being the same. Right now, on the right side of the equation, we have 27 to the 1st power, and on the left side we have a 3 for a base. So the bases are different, but I can write 27 as 3 cubed. So I can convert it into 3 cubed, so now the bases are the same, so therefore the exponents must be equal. So 2x minus 1 must equal positive 3. We can then solve this for x. We can add 1 to both sides. We have 2x equals 4, then divide by 2, so x would equal 2. All right, so that's the key for any exponential equation. It can vary in difficulty, but for this to work, what you need to do is get the bases to be the same on both the left and the right side of the equation. And then once you have that, you can then set the exponents equal to each other. Now, if you cannot do that, then you need to resort to another method. So if you cannot write both sides of the equation with the same base, you must take the log of both sides to bring the exponent out in the front. So for example, here we have 3 to the x power equals 30. We cannot write 30 with the base of 3, so therefore we want to take the logarithm of both sides. So we can take the log of any base, but we want to use either log base 10 or the natural log, because those are logarithms that your calculator can do, even the cheap ones can do. All right, so here we're going to choose base 10. We could choose a natural log if we wanted to. But here with base 10, we have log base 10 of 3 to the x power equals log base 10 of 30. So we can use our property of logarithms, where once we have a logarithm and we have something raised to a power, like we do here, we can take the exponent out in the front. So let's bring the x out in the front to have x times log of 3 equals log of 30. And then to solve for x, all we do is we divide both sides by the log of 3. And when you do that, we're now going to have log of 30 divide by the log of 3. So we have x equals log of 30 divided by log of 3. And we can then just type that into our calculator. So type in log of 30, then divide that by the log of 3. And we're going to get our rounded answer of 3.1. So therefore x would equal 3.1. And we can do this for expressions like this, where we have 3 to the x plus 2 power equals 4 to the 2x plus 1 power. We can do the same thing. So both sides we have variables in the exponents. So again, we can take the log of both sides. And when you do that, we again can bring the exponents out in the front. So the x plus 2 we can bring out in the front. So we have x plus 2 times log of 3. And this 2x plus 1 bring out in the front. We have 2x plus 1 times log of 4. All right, so now we can start solving. And in this one, we're going to want to distribute. So distribute log of 3, multiply it by the x, multiply it by the 2. So we have x times log of 3 plus 2 times log of 3. And then same thing over here, log of 4 times 2x, or 2x times log of 4. Then log of 4 times 1, or just log of 4. And now we have this line right here. So to solve for x, we want to bring x's together. So we can bring this 2x times log of 4 to the left side by subtracting. So when you do that, we're going to have x times log of 3. Then we have that minus 2x times the log of 4. And then equals, we can bring this 2 log of 3 to the right side. So now we have the log of 4. And then minus, we can subtract that over. So minus 2 times the log of 3. And we see that typed up right here. So then from this point on the left side, notice they both have an x in common. I can factor that out, and you're left with x on the outside and then we have log of 3 minus 2 times log of 4 in the parentheses. And then from here we can solve for x by dividing by this log of 3 minus 2 times log of 4. When you divide, that's going to cancel over here, and on the right side you're going to have log of 3 minus 2 times log of 4 in the denominator. And we see that typed up right here. Alright, now at this point we can type this into our calculator. So we type in the log of 4, and then we type in log of 3, then we subtract them, so log of 4 minus 2 times log of 3, and then do the same thing at the bottom. We have the log of 3 minus, and then 2 times log of 4, and at that point it's just typing in things into your calculator, and if you do it correctly, you should be getting something around 0.5. So x would be approximately 0.5. Now, another type of exponential equations we want to work with are equations in this form, where we have b to the x power plus b to the negative x power. So for example, here we have 3 to the x power plus 3 to the negative x power, and that is equal to 8. So there's different ways you can approach this, but one technique is we can multiply both sides by 3 to the x power. And the purpose of doing that is because on the left side, when you distribute, we would have 3 to the x times 3 to the x power. You add the exponents, which would be 3 to the 2x power. And then here, 3 to the x power times 3 to the negative x power, you would have to add the exponents, x plus negative x. That would give you 3 to the 0 power. And that's equal to 8 times 3 to the x power. All right, so then from here, 3 to the 0 power is 1. So we have 3 to the 2x power plus 1 equals 8 times 3 to the x power. And then we can set this equal to 0. So let's bring the 8 to the 3x power to the left side. So we have negative 8 times 3 to the x power, and then plus the 1 equals 0. So from here, what we have is an equation that is in quadratic form, where if we let u equals 3 to the x power, then u squared would be the 3 to the 2x power. So we can replace that with u squared minus 8 times u plus 1 equals 0. So now we have a quadratic equation that we can solve. We can use a quadratic formula or completing the square. If you use a quadratic formula, we're assuming you know how to use that, but we do the opposite of negative 8, so positive 8, plus or minus the square root of b squared, so negative 8 squared, or 64, minus 4 times a, so 4 times 1, times c, which is also 1, all over 2 times a, which is 2 times 1, or 2. So we have 8 plus or minus the square root of 64 minus 4 is 60, all over 2. 60, we can simplify that square root. So 60 would be, 2 times 30. 30 is 2 times 15. So we have 2 times 2 times 15. So we can factor a 2 out. So 8 plus or minus 2 times the square root of 15 over 2. That would reduce, divide everything by 2. We have 4 plus or minus the square root of 15. So all of that was to find us the value for u, and then at the end we need to back substitute. So meaning, if you look up here, we have 3 to the x power. That was equal to u. So we have 3 to the x power equals 4 plus or minus the square root of 15. So we see that right here. And then from this point, we can try to find x by taking the log of both sides. So now we have something that we've seen like in the previous example. We can take the log, so log base 10 of 3 to the x power equals log of the 4 plus or minus the square root of 15. And then we can bring the variable, this exponent, out in the front. We have x times log of 3 equals the log of 4 plus or minus the square root of 15. And then we can solve for x by dividing both sides by log of 3. So that would give you log of 4 plus or minus the square root of 15. All that is over the log of 3. Now you could leave it like this. This is the exact answer. Or you can type it into your calculator. The only thing you want to take into account, or at least consider, is right here, this part. If you have 4 plus or minus the square root of 15, you want to make sure that's not going to be a negative number. So here it would not be, because the square root of 15 is going to be 3 point something. So if you do 4 minus a 3 point something, it's going to be a positive number. All right. So if it was like the square root of 17, you'd have 4 minus 4 point something, which would give you a negative number. And you cannot have a negative number in this location. So here we actually would have two different answers for x. But then if sometimes there may only be one answer, just got to check the minus part. And if you did decide to type that in your calculator, we're going to get approximately plus or minus 1.88 as your solution. So all of that was dealing with exponential equations. Now, for the last part of the lesson, we want to work with solving logarithmic equations. So for example, let's say we had the log of 5x minus 10 equals 3. So the key for this one is we want to get out of logarithmic form and write in exponential form. So if the log does not have a base written, there's an assumed base 10. So we would have 10 to the third power equals the 5x minus 10. 10 to the third power is 1,000. We can solve by adding 10 to both sides. We would have 1,010. And then we divide both sides by 5 to get x equals 202. So our solution is 202. Now there's times when you have something like this, for our second example, where we have two logarithms on the left side. And to do this, we want to use our logarithm properties to combine into a single logarithm, as we saw here for example 1. So for this one, we see a minus sign, which means we can combine the logarithms by dividing the x and the 2. So what we have is log of x divided by 2 equals 1. And then from here, we can get out of logarithmic form and put into exponential form. So we have an assumed base 10. So we have 10 to the first power equals x over 2. And then solve this for x, multiply both sides by 2. So we'd have x equals 10 times 2, which would be 20. So our solution here is 20. Let's try another example. Here we have, again, another logarithmic equation. And now we have two logarithms on the left side. We have one on the right side. So for this one, again, we want to combine the left side into a single logarithm. So, and again, we see subtraction here. So with subtraction, we can use our logarithm properties to combine into a single logarithm by dividing. So what we divide would be the x plus 6 and the x. So what we have would be log base 9 of x plus 6 over x equals log base 9 of 2. Now when you have an equation like this, where you have logarithms on both sides with the same base, we can use our one property that says that if we have this setup, that part and this part must be equal. All right, so what we have would be x plus 6 over x equals 2. And then we can solve this by multiplying both sides by x. That would give you x plus 6 on the left, and then 2 times x on the right. And then let's bring this x to the right side by subtracting. That would give you 1x on the right equaling 6. So your solution is x equals 6. All right, let's try another example where here it's very similar, but we have an x squared part. So we'll show you how to work with that here in a moment. But to do this one, again, we want to combine into a single logarithm here on the left side. So for this one, notice we have a plus sign right here, which means we can combine the logarithms by multiplying. So what you're multiplying is the 6 and the 2x squared. So we combine to get log base 5 of 12x squared equals log base 5 of 48. And now from here, again, the same concept. We would set 12x squared equal to 48 because the left side and the right side both have log base 5. They're identical, so we can set those equal. So we have 12x squared equals 48. And again, same idea. We just solved this for x. So we can divide both sides by 12. So we have x squared equals 4. And then when you take the square root, we would have x equals plus or minus the square root of 4, which is plus or minus 2. So for this one, we have two possible answers, where x could be positive 2 or x could be a negative 2. And the only thing to remember for all of these is whatever solutions we get, we want to kind of think through and double check if you plug it back into the original equation, you plug it back in for x, you need to make sure that this part in here is not negative. Now in this case it's not, because negative 2, if you plug it in for x, negative 2 squared is positive 4, times 2 is positive 8. So that's fine, but just be aware of that you should always kind of double check to make sure that that part inside is not a negative number. Now to finish off, let's talk about an application of this concept. Now there's applications in all different contexts. Here we just give you one kind of a random example. And here we are told that scientists have found that the length in inches of a certain species of electric eel can be found by L equals 22.4 times the natural log of W minus 28.7. where W is the eel's weight in pounds. Find the weight of an eel that is 4 feet long, and round your answer to the nearest tenth of a pound. Alright, so what we're doing here is we're trying to find the weight, which is the letter W, and we know the length is 4 feet long. 4 is going to be the L value. L is the length. So what you do is you take that equation and then you plug a 4, or actually, well, the length is in inches, right? So the length is going to be 4 feet or 48 inches, so put a 48 here, and then you can solve this for W. So we have to get this natural log of W by itself, so we want to go in reverse order of operations. We can add 28.7 to both sides. So when you do that, we're going to have the 22.4 times the natural log of W on the right. And then 48 plus 28.7 is 76.7 on the left. And then we can divide both sides by the 22.4. So when you do that, you're going to have natural log of W on the right. And on the left, we have 3.4241. Now at this point, we want to solve for W, but the W is inside the natural log. What we can do is we can convert into exponential form, where the natural log has an assumed base e. So we have e, and then to the 3.4241 power, that would equal W. So that should be a 2, I believe. So 2 right here. So we raise it to that power, and then just type that in your calculator, and we're going to get 30.695. So that means that an eel with a length of 4 feet would weigh about 30.7 pounds. So that concludes our lesson for today. We will see you next time.